cast iron construction, and this is the skeleton and skin method. The skeleton and skin method applies to wood balloon frame construction as well, but that's the overarching segment, or the topic is skeleton and skin. Below that is cast iron, and then we'll get into balloon frame. Okay, but these two different construction methods, the first is cast iron that we're going to look at, developed in the 19th century. So iron's been around a long time. You know, we have the Iron Age. We have a lot of cultures using iron in the past, but not in a larger scale way. Definitely not in architecture, just objects, small things, because they couldn't forge it or cast it. They couldn't smelt it, meaning, melt it down and pour it and process it on a larger scale till the Industrial Revolution. So you always want to remember the Industrial Revolution changes many, many things. Graphic design was one of our big areas where things changed, and that's on your final. But you also want to think about what else did it affect. So we have these new factory sort of settings, these ways of manufacturing cast iron, so we can make these massive structures. Okay, the first one's the Crystal Palace, which I don't have a slide of, but it's in your book, page 299. But the Crystal Palace didn't survive, unfortunately. No really good reason there. I mean, it wasn't built as a permanent structure, but it actually was strong enough to stand, but they just thought of it as part of a curiosity and just a sort of an exhibition, not really a real building. Then that was in 1851, and then we skip ahead to 1889, 30 some years later, in Paris, and we build the Eiffel Tower. Now this also was for the World's Fair at the time, and not really intended to be a permanent structure. And there are stories too about how this was actually going to be skinned with another material, and this is the one of the very few, if not the only, structure with just the metal cast iron showing. Beautiful structure, well thought out. You can actually climb up in this. There's staircases. You can't really see them, but there's staircases along here and then down along the leg, and you can go all the way up to the top as well. But the Eiffel Tower, made by Gustave Eiffel, that's named after the architect, is cast iron construction, and we can see the skeleton, but there is no skin. Okay, so balloon frame construction is also a skeleton and skin method, and you're going to develop a framework, and it's usually wood, pretty much always wood. I think anymore with our concerns about the environment and forestry and things like that, some of the materials that are getting used in green architecture are starting to replace wood, but for the most part it is wood. It's such a versatile material. It's very, very useful in terms of creating a structure very quickly. Okay, so two innovations here listed: improved methods for milling lumber, similar to how cast iron had improved methods in the Industrial Revolution. That's also true for milling lumber, because you think about machinery now. We have steam engine, and then later we have gas or other diesel engines, electricity at a higher power to cut logs in half and so on. And then also mass-produced nails. Nails used to be made by blacksmiths, so think about that, one nail at a time. That's pretty brutal. So here we are with balloon frame construction. I think all of us have seen this driving around at some point or other. You see the sort of 2x4 construction here, and then you get your particle board or plywood. This is particle board here. Plywood is more of a flat sheet of wood onto another sheet of wood. Particle board is chunks of wood that are laminated together. Both of them use glue. Okay, so mass-produced nails, if you think about that, then all this stuff's readily available. And then we also have like these things like these brackets and so on like that. So this is balloon frame. We get the structure, the interior and the exterior, all in one go. the walls and all that stuff can be popped up in a kind of a quick fashion, and then, and this is our skeleton, and then the skin can be put on very quickly after. Okay, steel frame construction. Steel gets a little more sophisticated than iron, and it also uses skeleton skin. Steel frame is strong. Steel is stronger than iron in terms, and it's lighter, so we can go higher. This is how the skyscrapers were invented. Now, the reason the skyscrapers could exist and people are not going to walk 40 floors to their office, of course, is the elevator. So the elevator was an innovation, and after a certain amount of time, I would say 10 floors, 12 floors, people are really not going to walk up that many flights of stairs several times a day. So the elevator enabled the buildings to go even higher. Okay, Leverhouse, Gordon Bunshaft of Skidmore, Owings and Merrill. Huge, big deal architectural breakthrough here. This is 1325, page 303. Previous to this, you want to observe the Wainwright building, because that was the first breakthrough with the steel construction, and this becomes the international style, is what it's known as, and this is the height of how you can get the building to look